This is lesson 7.4, writing equations in two variables, chapter 7. An equation in two variables represents two quantities that change in relationship to each other. For example, the bill you pay at a restaurant, depends on what you eat. Same way, the amount that you pay to the cashier at a grocery store depends on the number and what grocery items you buy. So one thing is dependent on the other. So a solution of an equation in two variables is an ordered pair that makes the equation true. Since there are two variables, we take it as an ordered pair. Now, the variable that represents the quantity that can change freely is called the independent variable. Remember this from science? We call it the independent variable or the manipulated variable. And if I'm not mistaken, you were asked to remember the MIX for independent variable, which is manipulated variable, independent variable, and it goes always on the x-axis. And the other variable, which is the dependent variable, because its value depends on the independent variable. This is the dependent variable, or remember the dry, the dependent variable or the responding variable, which always goes on the y-axis. Again, there's no difference in graphing in math and science. Okay, let's go ahead and identify some independent and dependent variables. Again, usually when something is equal to, and this is your answer, this is always the dependent variable. This is always the dependent variable. And these here, the variables that you multiply, variables you add or multiply, whatever you do on this side, these are the independent variables. These are independent. That's how you can remember. So remember this equation or equal sign. Everything or the answer that is on this side is your dependent variable. For example, in this, we have the equation y equals 16 minus 2x, and it gives the amount y in ounces of a trail mix that is left over or remaining after you eat x servings. So what depends on what? Your y depends on how much you eat. Remaining depends on how much you eat. So the independent variable in this case is the servings, which is the x, the servings you eat, and the dependent variable in this case is the y, which is the trail mix remaining, or you can say leftover. All right, let's go ahead and I want you to finish the second one. The video membership costs $14 a month for 10 video rentals, and each additional rental is $2. So I want you to figure out what the independent variable would be and what the dependent variable would be. That means what are you changing and what is changing. Cause and effect. Think of it that way. The best way to think about it is cause and effect. All right, let's go ahead and take a look at number 3. They're asking you to complete the table by describing possible independent or dependent variables. And that's the key, possible independent or dependent variables. I'll do the first one, but and this is just an example. You will do not use the same. Do not use the same example. I want you to use some other example and fill this dependent variable here other than the one that I'm showing. Okay. For example, the number of lawns you mow is the independent variable, and the money you earn. So let's say you were doing it for a business. the dollars you earn depends on the number of lawns you mow. So this is my example. I want you to come up with an example. Do not use any form of money. There are plenty of other things that you can think about. Just do not use money. Okay. The same thing here. In this case, I want you to fill in the independent variable when the dependent variable given is the number of shopping bags. So go ahead and fill these two in. Okay, let's move on to the next part, which is asking us to tell whether the ordered pair is a solution of the equation. Again, remember, when they say is it a solution, that means they are asking us to figure out if it is the answer of the given equation. We've just done this in the previous previous two sections actually, where they said x plus 4 equals 5, x equals 1, and then we had to plug in, remember that? So it's the same thing, but here we are doing with a coordinate pair. Again, remember, in a coordinate pair, the first number is always x, the second number is always y. The way you remember is x comes before y in an alphabet. That's how you can remember it. So I'm going to first, like usual, rewrite what I have. And they've said that the x is equal to 2 and the y is equal to 3. So maybe I'll just make a quick note here for myself that that's x and that's y. All right, the y, now just where you see the x and y, plug them in. The y in this case is 3. 3 is equal to, the x in this case is 2. Is 3 equal to 2? No. Put that line, not equal to, and you will say no. Same thing for the next one. Rewrite equals 8x, 0, 0. X value they've given is 0, y value they've given is 0. I have to see the substitution step. Don't give me straight away that whether it's true or not. So y is 0, so 0 equals 8 times, what's my x? So that's the y. X is 0. Okay. 0 equals, what's 8 times 0? 0. Is 0 equals 0? Yes. So yes, it is a solution. Go ahead and finish 7 and 8. Okay. Let's go ahead and figure out what the next one is. They've given us a distance formula, and this is something that you will see not only here, but wherever you use or you're trying to find distance, this is the formula you use. Distance is the amount traveled, or the distance traveled is always given by the r times t, where r is the rate of speed, it's a speed, and t is the time. T is the time and r is the speed at which they are, whatever is traveling. It could be you, it could be an airplane, it could be a motorboat, it could be a bicycle, it could be an ant, whatever it is. Okay, now they are asking us to write and graph the equation in two variables that shows the relationship between time and distance traveled. So when they gave us that the first one they want us to use is time, time becomes the x, distance becomes the y. Now, the same thing here, if you look, this equation is equal to the distance. It's equal to the distance. So RT is equal to D. This is our final answer. So this becomes the dependent variable. D is the dependent variable, or distance is the dependent variable in this case. All right, let's go ahead and solve this. A car is traveling at an average speed of 60 miles per hour on a road trip. They are asking us to use a graph to show the relationship between the time and the distance traveled. Now, in order to figure that out, I need a few coordinate points. And how do I get that? I get that by making a data table first. And I'm sure you are familiar with this from science. Okay. Remember, the independent variable always goes in the left column. So this is your x, always. And this is the y. Again, remember, x comes before y. So independent variable, and this is the dependent variable. That's the dependent variable. Okay. Now, once we make the data table, make sure that you label what the two variables are. In this case, this is time. Don't forget the unit. Time in hours. Let me write it here. Time in hours. and then this is the distance, and this will be in miles. And how do I get this? I get it from here. I get it from the fact that 60 miles per hour, that's where I get these 2 units. Okay, so for 1 hour I go 60 miles. For 2 hours, good, 120. For 3, good, 180. And for 4, 240 miles. Now 4 points are more than enough. I don't want you to do more than that. Okay, remember, when you're doing a graph, always label. This is distance traveled in time. Give it a title. Distance traveled in a given time. And always label your x-axis. This is time. Don't forget the units, which is hours. On this side, it is distance, the y-axis. And this is miles. Don't forget the units. I have to see these when you're doing your own. So x, that's the y. So start at 0. You can go up however, whatever way you want. I'm going to go 1, 2, 3, and 4. And on this side, I'm going to go up by maybe 50, 100, 150. Again, remember to jump equally. 200 and 250 is good enough for me. And go ahead and plot 1 and 60, so around here, right there. 2, 120, so just under here. 3, 180, just under here. And 4 and 240, just below the 250. Go ahead, connect the points. This is called, by the way, a linear graph, and that's it. That's the graph. We've made the graph. Okay, go ahead and finish the rest, and I'll see you next class.